Hi, I'm Eric, and today I'm going to tell you a little bit about something that really interests me. During high school, I decided to take an astronomy class. The teacher had an enormous impact on my interest in the material. I think it was because he was laid back and showed so much enthusiasm during class that it made me really wonder how much I could learn about the universe around us. There's always something new to learn about the universe, and that's what keeps me so interested and intrigued. Do you ever just look up at the night sky and wonder how all those stars got there? For this speech, I'm going to explain the life cycle of the two various kinds of stars, low-mass stars and high-mass stars. Low-mass stars, like the Sun, are born in a region of high-density gas and dust called a nebula. Due to its gravity, the gas and dust contract, causing it to heat up and glow. Once this occurs, the star is considered a protostar, or a baby star. After it heats up about 15 million degrees centigrade, helium starts to form due to nuclear fusion with hydrogen. Because of the energy released from the nuclear fusion, the star stops contracting and starts to shine brightly. This stage is called the main sequence. After being a main sequence star for about 4.5 billion years, we finally reach where the Sun is at present day. And it will continue to be a main sequence star for about 6 billion more years until all the hydrogen in the Sun is used up and it can no longer form helium. The star will contract until the helium is hot enough to form carbon. Then it will start expanding again, cooling down and dimming. At that time, the star will be considered a red giant, as it has expanded about 250 times its current radius, consuming the Earth. Once the helium runs out, the outer layers of the star will drift away from the core, and when that happens, the core will be considered a white dwarf, until that stops shining, and then it is called a black dwarf or a dead star. A star is considered a high-mass star when it is equivalent to about 10 times the mass of the Sun or more. A massive star begins its life pretty much the same way as a low-mass star. A nebula contracts to form a protostar. As the protostar heats up, it starts to construct helium from nuclear fusion, and then it will become a main sequence star. Unlike a low-mass star, a massive star stays in the main sequence a lot shorter time than the low-mass star, which is about a few million years, before the hydrogen runs out and the star becomes a red supergiant with the helium core. Over the next few million years, by nuclear fusion, the star will continue to fuse atoms, including carbon, oxygen, and so on and so forth, throughout the periodic table. But once it reaches iron, the core collapses. The split-second collapse of the core causes a massive explosion called a supernova, sending all the created elements flying around the universe. Everything disappears after the explosion except for the core of the star. If the remaining core is about 1.5 to 3 times the mass of the Sun, the core becomes a neutron star. A neutron star is an object only about 12.5 miles long, but has the mass of about 1.5 times the Sun. Because of the power of the supernova, the neutron star spins about 43,000 times per minute, which is pretty insane if you think about something with such big mass spinning so fast. If the remaining core is greater than 3 times the mass of the Sun, the core becomes a black hole. A black hole is an object that is so dense that not even a light particle or a photon can escape its gravitational pull. Some black holes have so much mass that they are actually able to keep millions of solar systems and stars around it in orbit, creating a galaxy, like our own Milky Way galaxy. Those are called supermassive black holes. The life cycle of stars is pretty fascinating. Low-mass stars and high-mass stars are born the same way, but their deaths are completely different. When a high-mass star undergoes nuclear fusion, it creates all the elements that make up our world today. I feel it is so important to understand how stars live and die because it's pretty much understanding where we all came from. There's so much more to these structures than a simple glow they give off in the night sky, and there's still so much more to learn. Thank you for listening.